Okay, good morning. Today I'm going over how to solve this problem that involves natural logs. This particular video is on the Admentum Logarithmic Functions Mastery Test, number 1, okay? The question says, suppose the temperature in Denver, Colorado was 55 degrees when a 5-degree Arctic cold front moved over the state. Using K equals 0.012, how long would it take the puddle of water to freeze? And recall that the water freezes at 32 degrees Fahrenheit. So the first thing that we really have to do is get our knowns and unknowns identified in this problem. There's a lot going on, so it's really important that we get these correct, or else we're going to plug in the wrong numbers and that's not going to work for us. So the first thing that I have here is K is equal to 0.012. K is a constant, okay? So they just give that to you. So that's the first one that I'm going to put down because that's the easiest one that I know, right? From here, it's all interpreting the rest of the problem. So T0 is T initial, the initial temperature of the puddle. In this problem, it says that Denver, Colorado was at 55 degrees. That was the initial temperature of the city, therefore that puddle was at 55 degrees initially. The next thing is the temperature of the surroundings at present here. So it says that this cold front moved in, and that cold front was 5 degrees. So our surrounding temperature, R kind of stands for like room temperature, I guess you can say. That's kind of how I think of it. That temperature of the surroundings is the temperature of that cold front, which is 5 degrees. Our regular capital T without the sub-zero, this indicates the time the temperature after our time has passed. Okay, so it's saying that it's wondering how long it's taking, right, for that puddle to freeze, okay? So at the end of this scenario, that puddle is frozen. So we need to plug in 32 degrees so that we can make sure that we're indicating that that puddle is frozen at the end here, right? So this is present time temperature of 32 degrees, okay? The only thing we don't know, which is what we're solving for, is the time it takes for that puddle to freeze. That's little t. So I'm going to start pulling away here. This is our first equation, and it gives this to you, okay? And we have all of these parameters in here that we just talked about, the t, t sub 0, etc. And then we have our little e here. E is a natural logarithmic function, okay? So we have to use the natural log in order to cancel out the e. And we're not going to do that until the end. We're just going to keep plugging away and keep doing things algebraically until we get to that point, okay? So here we go. This is how we plug everything in. We have our, let me back up a little bit. We have our present temperature, our room temperature of the cold front. We have the 55 degrees of the puddle initially minus the cold front of 5. Again, we repeat the R here and here. We have our e to the negative kt. K is given. T we're solving. T is time. And from here, we're just basically doing algebra. We start by subtracting the 5 from both sides. Divide both sides by 50. And then from here, this is where a lot of students get stuck. Okay, how do I get rid of this e? How do I make this e go away so I can solve for t? And this is where the logarithm comes in. Okay, ln is natural log. I don't know why it's the L before the N, but this is how we represent natural log. So you take the natural log of both sides just like you would for any other equation. And what it does on the right is cancel out the e. okay? They're opposite functions. It's like ln to e is the same as plus to minus, right? They're opposite, okay? So we're left with the negative 0.012t is equal to negative 0.616. All I did was plug this into my calculator. There's a function called ln. So make sure you're clicking the ln, not the regular log, okay? And this is what you get, all right? From here, you just divide both sides, and you will get your final answer. And I'm not going to reveal the final answer because I want you to actually solve this problem and not just look at the answer and go, okay, that's the answer, and put it in the computer. I want you to actually learn this stuff, okay? So I hope this was helpful for you. I will continue making some videos for you. Thanks. Bye.